Alright, so this is part 3 in a series of videos where I'm explaining why the numeral called dec looks the way that it does. Now the way that it looks is the shape of an X, where there's a little tail off of one half of those two lines that make up the X. So you can see the little tails kind of go that way in there. And there are examples of this pattern on the internet, or that geometric symbol, if you want to call it that, the numeral for dec. So it's connected to this geometric pattern, and these lines have a slope of going up 1 over 0.7, up 1 over 0.7, and the distance between these points, when you do that, is the distance of 0.5 root 2. And then if you go along here, you go up the distance of 1.1, and the distance between those 2 points is 0.5 root 2. So you can create a polygon by connecting these points, and that geometric pattern is connected to the geometry of the circle, where you can use that geometry to come up with a diagram that divides the circle perfectly into 360 degrees. So whoever was using this geometry was doing it in base 12, and they were aware of the geometry of 360 degrees. So I've written a book about that called Understanding Base 12 Math, How to Draw the Perfect Circle Using Dozanal Geometry, and I explain how to divide the circle perfectly into 360 degrees in this book. So they're using that geometric pattern to come up with a symbol for the number dec. So what we're going to do is we're going to follow this line here. You can see I've drawn it. We do 2 iterations of going up 1 over 0.7, up 1 over 0.7. Then we go up half of 1, which is 0.6 in base 12, and then an over 0.36, half of 7, and we come to this point here. So the coordinates of that point are negative 1.56 and then 2.6 for the height of that point. And then we draw a very short line. It's the length of 0.5, and that brings us to this point right here. So the x coordinate of that point is negative 1.dec6. Okay, so we have that little tail on this half of the x, and then we do the same thing down here. We go down the length of 2.5 and then over 0.5. So now we can draw a line that goes all the way down. We can figure out that same point down here, but the question is, that would, if we did the same thing on this side, then we would have 2 lines that have that little tail, but we don't. So we've now figured out what this pattern is here, why we have that little tail. We're landing on points that are very close to the circle with the radius of the square root of dec. In the next video, I'm going to show you what geometric pattern is revealed when we simply connect those 2 points right there.